Okay, so shall I start? First, now the topic is about development of educational robot for learning the computer science. Actually, the mostly we have developed it for learning the computer science courses, so like embedded systems, the Internet of Things, programming, actual different things. So now, first I will talk about it. Important in STEM education actually, and also which review that we have done. What we have done with this education, and also our publications that from where we have inspired to publish some papers. Okay, actually, the education robots, they are very popular in STEM education, in science, technology, engineering, and math education, because in the starting from the kindergarten, primary school, secondary schools, actually the students, for students, they are given this kind of education robots. Actually, it is not programmed, so it is like a hardware, and then the students program themselves this educational robot, and then they will see what is the output from their algorithm, from their program, actually. So in such case, using this kind of educational robots, they develop their tangible thinking. It means that how they see the real world applications, I mean that their algorithms, the applications in these educational robots in real world, and also their problem solving skills, like working with a team, and also another thing it is that their logical thinking. So the algorithmic thinking, of course, then step by step how to solve this kind of problem, step by step, seeing with hands-on learning activities actually. So then, since our computer science or the engineering, they are very similar, because the computer science is mostly used in the higher education, but STEM education is used in the secondary or the primary schools. So then we thought that we have hypothesized that this kind of education robots also could be used in the higher education, where students, they can apply their programming code and they write their own programming code algorithms to this kind of education robots, then apply it, and then they will see what is the output, and how do they work with these education robots. Actually, yeah, this is the education robot. Actually, it is where we have started. Actually, it was supported by the government of Greece Republic. It was kind of international project there with my external supervisor from the Haroupa University of Athens. Actually, they have created such kind of education robot. Then have so how we can create or how this kind of education robots, they support different computer science courses, including like algorithms course, programming, embedded systems, the Internet of Things, computer vision, data analysis, or AI, or different courses could be supported using this kind of education robots. It means that students, they write their own code to this one, and using the different sensors and actuators from these education robots, so they can run their activities. Actually, for example, if they have the camera, for example, using this camera, they can get the real world data from the environment and then apply their algorithms to this one. Actually, for example, one of the example was that we have used reinforcement learning actually for the machine learning. With this one, how robots react, or also robots, they work collaboratively in one space, in one room. So then, yeah, the problem with these education robots, actually, most of them, they are used in the STEM education, and for the primary schools, kindergartens like this one, now how we can use this kind of educationals in higher education. And also another problem, it is with their cost. So when we compare their cost of the educational robots, actually from there, the most popular ones are Europe, for example, Hydra or Lego, for example, which is mostly used nowadays in the in competitions and also in the STEM schools, actually. Yeah, they have very high cost. And then, for example, if you want to apply this kind of educations in the higher education or in the education, actually, yeah, you have to buy several of them. For example, for every group, in this case, it will cost huge budget. That is another problem. And then most of them, they are their level of education, they are secondary education. In kindergarten, for example, female too, for example, it is in kindergarten, And then Edison, for example, also could be used in elementary or secondary schools. Now, in our case, we are applying the education robot, which could be used in the higher education, and also to support different courses from the computer science and also engineering based classes. So now what we have done, actually here we have an education robot. We have called this as I2Explore bot, which comes from the education robot for exploring the Internet of Things. And then we made it kind of the open source with GitHub, because anyone else who wants to get to duplicate this kind of education robots, they can run their build their own educational robot, and then they can run it in their closet actually. So then, yeah, it is low cost because their approximate cost, it is 55 euros. It is overall for these things, for their chassis, and also the microcontroller we use. It is microcontroller. It is kind of the tiny computer use, which has the limited power, limited processing power, and random access memory. And then, so then we have continuously improved our robot. Actually, we have started from here. First, we have used kind of cardboard, and then it was the very first prototype, and then we connected with the Technopark, and then we have created such kind of the chassis, which is made by wood laser cut from there. And then, actually, yeah, it is kind of the sustainable because compared to other education robots, for example, these ones, which they use the plastic actually, then this one also they use the plastic. In our case, it is more sustainable. We made it, and which is also costs less than these ones. And when you print using such kind of, in case of the open source education robots, yeah, we create our own education robot. In such case, for example, when you want to print some kind of plastics in 3D printers, in this case, it takes much time. Actually, this one, for example, which actually we have seen, we have used them in the Harakopy University of Athens during my internship. Actually, it took more than 24 hours in order to print one robot. But actually, in our case, for this one, it takes some minutes actually to get such kind of the shape. So then, what we have done, it is next, we have created such kind of PCB. It means a printed circuit board. So then, the ones who are beginner, they can directly connect to this board, and then connect their sensor actuators, and then it works. Actually, like a plug and play. It would be kind of for starters, it would be very easy. And also, for example, who the students in other courses, who they don't have enough experience with the embedded systems, actually they can just plug and play with this kind of the robot, and then they will write their algorithms, their programs, and then apply to this kind of robot. So this one is the latest version. Actually, we have also the experience with different microcontrollers. It could be for Arduino Uno, for example, first, then Raspberry Pi RP2040. It is a microcontroller also, and then another part, it is the Arduino IoT33. Yeah, different ones. And the last version that actually we have used, it was the from here we made it compatible with the other microcontrollers from the Arduino family, because the Arduino, they have different kinds of the microcontrollers which are developed for different tasks. For example, some of them they could run with the camera, some of them they could run with the different Wi-Fi, Bluetooth. They have different connectivity. Also, that is very important with the working with the hardware. Then, how we can connect with the education robot? Actually, the first thing it is students, they have their own computers. So then, using this computer, they write the code. Then upload this code to this robot. So this could be done using the USB cables, or it is over the air, OTA code over the air. So then Arduino, actually, they have such kind of the capability, which gives that we can program them over the air. So once you upload the code, so then if you want to make some kind of change to this code, you can, without connecting this robot, or this microcontroller to the computer, we can program them. It is one thing, we can do it. And after that, actually we have this microcontroller, it is the Arduino IoT33, which has the built-in Wi-Fi wireless connection and also built-in Bluetooth low energy. So then using this one, we can also connect to the mobile phones. So then means that students, they write on code, and then using the Bluetooth from with the mobile phone, they can control this robot. This could be one task. The another task could be like get the data and upload it to the cloud. So there is kind of different cloud technologies are available there using this kind of microcontrollers. One of them is the ThinkSpeak, for example. Another method could be also the Arduino IT Cloud. They call it Arduino IT Cloud. So also they upload this data, and this data also could be observed using your end devices, mobile phones, computers, and also students also they can write their own applications with the computer, also which connects through this cloud, and then using this application software they can control also these robots during the, and see that what do they can have. Okay, so now how we can now design the activities for this robot. So actually, the first thing we need to choose the relevant courses, okay, which course could be used or could be supported using this kind of the robots. But then we map the course to the robot activities. Like first, we need to define the programming libraries. So for example, if it is using the Python, so we can use different Python libraries from the Python. Also, from the if it is C++ or C based programming language, in this case, also we can define the language and also define the hardware. Okay, which types of the hardware components, sensors, actuators we can use in this activity. So, for example, if you are going to use them for the computer vision, in this case, yeah, we can use the camera, for example, if you want to apply some kind of algorithmic skills. For example, in this case, you can apply some kind of the actuators. In this case, yeah, we need to define the hardware components, and then we can just take the indicative activities based on this robot in the course. Okay, so then different computer science disciplines could be used. For example, some of them could be used in this kind of the robots, the electronics and circuits. For example, there we can just, students, they can work with this robot. So just selecting which, for example, resistor they need to use, okay, how to connect these things, electronic, in the electrons, we can use them. Another thing is embedded systems, for example. If we use them with different microprocessors or microcontrollers, they allow the students to interface directly with input and outputs. And algorithms also, for example, they run their algorithm, that develop their algorithm and then run in this robot. Also could be done. And data science, since that the robot has the different sensors, so we can collect the data in a real time, and then we can see what is happening in the real time. Actually, that is very good to also, to measure data from the environment. And then AI, for example, some microcontrollers and microprocessors also, they enable the AI, but for this kind of the microcontrollers, we need to use the tiny machine learning models, not the model that we are using often, but it is tiny. It means that, so we create a model and then we just adapt this model for the limited processing power. Which is, so for that one could be used different platforms like Edge Impulse, for example, tiny machine learning, also from scikit learning. Also, they also have the different models actually platforms where we can just adapt our models. Then also for computer vision, for example, use the camera for object recognition, and then if recognize some kind of the object, it makes some kind of the actions also could be done during this robot. Yeah, these are some indicative activities, which activities could be done during the different sensors of the robot. For example, if we use the like microphone, for example, microphones, they can get the voice of the student and then capture it, and for collecting data also we can use it, for example, or the speakers, for example, communicate with the learner. Actually, also that could be supported with the other disciplines rather than the computer science. And ultrasonic sensor, for example, which measures the distance between the robot and the object closer to this robot, actually also could be used with different activities. Yeah, we can just design first activities and then run them in the robot. Now in order to experiment a robot, whether it is effective or not, what we have done, it is that during the spring 2023, that we had a course called Introduction to IoT to the bachelor's level students in third or second year students. They attended in this course, and then we have divided our students into two groups by their sections actually. And then first group, they used the experiment. It was an experimental group. They used our robot. So we have designed different activities. And then another group, they used the activities from the previous year's ones. So it is kind of, we can say, the traditional activities where they use the packet tracer desktop applications, or then they use made of the kits, Arduino kits like this one. It is kind of based on traditional group. So then we have designed 10 structured activities. So then students start with the basic activities, and every time they develop their own robot. So they apply these sensors actuators to the robot, they write their own code, and while students, they are getting more knowledge, also they develop their own robot for better, to make it better. And then the last activity also about was the cloud, how we can communicate with the cloud, and then we can control our robot through the cloud, through the internet, like this one. And most focus area was some kind of the communication. We use the network, data collection using the sensors, and another one is sensors using this one, and also the control of this robot. But then, for these 10 activities, actually we have evaluated the students. If you can see from here, for the control group, it means which they use the traditional method. They have the not much higher, but they have a little bit higher percentage for their activity grades. 65, almost 66, but here it is 64 for experimental group. But then, what we have done, we have given the project for all students, and the project requirements was the same for control group and also the experimental group. And we asked them, so you can use anything else. So the experimental group, they could choose the robot, or they could do with the other works from the traditional groups activities as well. So then, when we compared the grades for the project, actually, experimental group did it well than the control group for now. And then from there, we can just say that it increased their interest, engagement, and also the thinking skills, actually, that interactive skills with this one. Also, we have developed, collect the qualitative data, which shows that 88% of students report that the robot is kind of enjoyable, highlights its positive impact on motivation and hands-on learning activities. Okay, now, based on this work, we have published 4 works. Actually, the first work, it is about how we can use the education robots in the computer science application, computer science course disciplines as well. There we have made some little review, and we have proposed, how we can use the education robots in creating the computer science curriculum, and also the applying in different computer science courses for learning activities. And then another work was preliminary findings of our robot, which was published in the conference paper. And then extended paper work of this one, we have published in another paper, that is Q3 from the Web of Science. It is called as Development of an Education Robot for Exploring the Internet of Things. And then lastly, also another conference paper where we have discussed about our findings, what we have learned from there, like a case study, how we did the experiments, how we have created such kind of the activities, how we have applied all these things. So actually, I was inspired from this one. So this picture was taken from one of my seminars workshops I have attended in 2023 in Tashkent. No, it was in Samarkand, actually. Yeah. So then, how we can publish different works, several papers in one project. not only 1-2 papers, but several ones. For example, we can make some kind of the literature review and then apply our text challenge or opportunities, and there our what do we have developed, all the things. Then at the end, also we can use some kind of case studies, also the lessons learned, like best practice. All these ones also could be applied as a published as a paper. So in such case, yeah, we have done like this one. So we have published it for papers for this work, actually, what we have done so far. Yeah, that's it from about our work. But if you have any questions, yeah, you're welcome. Yeah.
So you were able to make many robots instead of 3D printing.
You mean
you were able to make it more sustainable?
with
The IoT Explore one.
yeah. In this case, yeah, because the 3D printers they use the plastics. One of them.
But the iExplore bot uses what?
It uses the wood. It is this top. This one. It is made from the wood cut. Actually, it is they use the lattice, so there is big machines. Actually, there is. So then we put the flat wood. So then it used the lasers to cut this, and then we just use the we just compose this robot to this one. Actually, it is very fast. But with the 3D printers, yeah, it gets much time for these ones with plastics. Yeah, it took 24-25 hours for one robot for this one. What we have done in the Greece, this one, for that one. But here, it takes less time. Actually, in some minutes, it can cut the wood with this one. So what you have done to do it is first design it with the computer and then send the instructions, and it will do it very fast with it. So we can just create several robot-shaped chassis in limited time. Yeah, Professor.
The students have experience to make a program from the
Yeah. Yeah, no, actually, you mean this one, right?
No. Before taking your lesson, the student had experience.
No, actually, yeah. In this case, yeah, they are second and third year bachelor students. Actually, they know the different programming language, maybe Java, for example, Python, but they never, most of them, they never had the experience with Arduino. It is first time. So in this course, we just give, it is just starting course, because before this course, actually, they did not have such kind of the course. Maybe they have the background from the electronics or digital design like this one, but still in electronics, they don't use the Arduino. In such, yeah, they first came and learned about dating. So that's why when we have designed the activities, they start with the basic activities. It means that just how to use the print hello world. So they start with it, then every time they get more experienced with this one.
So how to teach them about the program?
Yeah, parallelly, actually, when we teach this one, we have the lectures, and during the practices, we gave the first how to use this kind of the microcontroller, and also we give their programming. Actually, they have the programming basics. They know how the programs work, but what they need to know now it is how they can apply their programming knowledge into this kind of into Arduino language. That it is C-based language. So actually, yeah, but for most of the students who are very good in the programming, still, if they have the middle level, they can do better with the Arduino because its program is very simple, actually. Okay, if no questions, can we finish?